GeopByte.
Welcome to GeopByte. Hi students, in the previous video we have covered the topics Introduction to Real Numbers and how to locate root 2 and root 3 on the number line. In this video, let us cover the topic exercise number 1.2. Now, let us see exercise number 1.2. In that, the first question is, state whether the following statements are true or false. Justify your answers. Right? It is given that we have few statements. We need to check whether they are true or false and justify the answers. See, these are the three statements. Let us see one by one. The first statement is, every irrational number is a real number. Yes, it is true because real numbers are a collection of rational numbers and irrational numbers. So, every irrational number is a real number. It is true. Let us write. True because rational numbers and irrational numbers form a collection of real numbers. So, this is the justification to the statement. Now, let us see next statement. Every point on the number line is of the form root m, where m is a natural number. See, on a number line, if we have the number in the form of root m, where m is a natural number. See, in under roots, there will not only be natural numbers, there can be whole numbers, integers and rational numbers and irrational numbers. So, only m cannot be natural number. There might be any other number. So, every point on the number line is of the form root m, where m is a natural number. This statement is false. Let us write. False because m might be an integer, whole number, rational number, or irrational number. Right? M cannot be only natural number. It might be an integer, whole number, rational number or irrational number. So it is false. Let us see the last statement, that is third statement. Every real number is an irrational number. It is false because real numbers are not only irrational numbers. Real numbers are the collection of rational numbers and irrational numbers. So, every real number cannot be an irrational number. So, let us write false because real numbers are a collection of rational numbers and irrational numbers. So, the third statement is false because real numbers are a collection of rational numbers and irrational numbers. So, every real number cannot be an irrational number. Now, let us see second question. Are the square roots of all positive numbers irrational? If not, give an example of the square root of a number that is a rational number. It is given that are the square roots of all positive numbers irrational? They are asking us. So, if not, give an example of the square root of a number that is a rational number. So, let us see whether every positive number under roots are irrational or rational. Let us see with an example. Let me take a positive number 9. So, if I take 9, under root 9 is equal to 3. Under root 9 is equal to 3. So, I got a rational number. See, 9 is a positive number, but I did not get irrational number. I got rational number as the answer. If we see with one more example, root 16 is nothing but 4. Here 16 is also a positive number, but we got a rational number. So, by this, it is proved that are the square roots of all positive integers irrational? No. Right? The square roots of all positive numbers are not irrational. They are rational also sometimes. If not, give an example of the square root of a number that is a rational number. See, these are the examples to show that under root, if a positive number is there, we get answers as rational numbers. So, that is false. That statement is false. Now, let us see third question. Show how root 5 can be represented on the number line. Right? Let us represent root 5 on the number line. See, as you know, root 2 lies between 1 and 2. And root 3 also lies in between 1 and 2. Root 4 lies? No, it will not lie because root 4 is equal to 2. Right? So, it is exactly 2. Now, root 5 comes after root 4. So, after 2, root 5 comes. That is, in between 2 and 3, root 5 comes. Now, let us consider a rectangle of OABC with two sides of 2 units length and another two sides of 1 unit length because it is a rectangle. 2 longer sides, 2 shorter sides. So, 2 units, 1 unit, 2 units and 1 unit. So, this is my rectangle O, A, B and and C. Now, let us join this line. Now, this is my 2 units length. Let us write 2 and this one is of 1 unit length. Let us write 1. Now, see, we can find a rectangle that is of this type. So, O, A, B. Now, OA is 2, AB is 1. So, by using Pythagoras theorem, we can find hypotenuse. Let us use the formula Pythagoras theorem. Hypotenuse square is equal to base square plus height square. Now, hypotenuse is nothing but the longest side, which is OB. So, OB square is equal to base is nothing but OA. So, it is 2 square plus height. Height is nothing but AB, which is 1. Let us write 1 square. Now, OB square is equal to 2 square. 2 into 2, 4 plus 1. So, OB is equal to under root of 4 plus 1, which gives OB is equal to root 5. So, let us write OB as root 5 and here also root 5. Now, take a compass. O as center and OB as radius. As we are marking root 5 on the number line, OB should be our radius. So, keep pointer at 0 and radius of OB, draw an arc. It comes like this. If you draw an arc, it comes like this. So, this is our point root 5. So, this is the way to locate root 5 on the number line. Now, let us see fourth question. Classroom activity. Constructing the square root spiral. See, let us construct a square root spiral on this number line. First, let us consider a square OABC. That is with each side 1 unit length. This is our square O, A, B and C. Now, see, this side is of 1 unit length and this side is of 1 unit length. If we join OB, then this will be root 2. As we have solved by using Pythagoras theorem, under root 1 square plus 1 square is equal to root 2. So, as this is a triangle, by using Pythagoras theorem, base square plus height square, we got root 2. So, now let us keep O as the center. Take a compass and put O as the center and OB as the radius. OB as the radius, draw an arc that comes here, that is root 2. Now let us represent root 3. See, this is our line. For this line, let us draw a line perpendicular, that is exactly 90 degrees. Take a protractor, put here. Take a protractor, put here, that is put along this line and draw 90 degrees line which is perpendicular to OB. So it comes like this. It is perpendicular, that is we got a right angle here. Now let us join these two lines. Now it becomes D, the point D, and see, this will be of 1 unit length. See, you need to draw perpendicular with 1 unit length. After drawing 1 unit length, let us join a line. So after joining, now this is our triangle. If you see base and height, root 2 square under root of root 2 square plus 1 square is equal to root 3. See, here square and root gets cancelled. So 2 plus 1 will be 3. That is, this one, the hypotenuse will be root 3. So let us take a compass, put O as the center and OD as the radius. Draw an arc, that is like this. It comes here like this. So O as the center, OD as the radius. Draw an arc, you get a point root 3 on the number line. Now let us draw a perpendicular line to OD. As we have drawn for OB, that is BD. Similarly, let us draw a perpendicular line of unit length, that is 1 unit length. For OD, let us put a protractor like this. So here it is 90. Let us draw. So if we draw that, we get a line like this which is 90 degrees to the line OD, that is 90 degrees. So now let us join this line. Now as I have drawn this line with unit length, let us write 1 and after D it is E. Now in order to find the hypotenuse, we need to use Pythagoras theorem. We have root 3 and 1. So by using Pythagoras theorem, under root of root 3 whole square plus 1 square. As we have root 3 and 1, if we use Pythagoras theorem, we can find hypotenuse. So root and square gets cancelled and 3 plus 1 square. 1 square is nothing but 1 itself. So 3 plus 1 will be root 4. Root 4. Now root 4 is nothing but 2. Root 4 is nothing but 2. So let us draw an arc by taking O as center and OE as radius. As this is 2, let us take O as the center, OE as the radius, draw an arc with compass. So it comes yes, it is at the point 2. Root 4 is nothing but 2. Now, let us draw a perpendicular to OE with 1 unit length. Same procedure, right? Let us draw perpendicular, that is, it comes like this. Perpendicular of this line will be this line with 1 unit length. Now let us join with this line. So after E, F, now we have 2 on one side and 1 on the other side. By using Pythagoras theorem, let us find hypotenuse. That is under root 2 square plus 1 square is equal to 2 square, that is 2 2s are 4 plus 1 square is nothing but 1, 4 plus 1, 5, which is root 5. Now we got the hypotenuse as root 5. Now take a compass, keep O as the center and OF as the radius, draw an arc. That is this is our point, which is root 5. So, taking O as the center and OF as the radius, I have drawn an arc, that is the point root 5 I have located on the number line. Now, let us take a perpendicular to OF. That is, it comes right angle with 1 unit length. As we are drawing perpendiculars with 1 unit length, let us draw this also, and now let us join this one. Now after F, G. Now we have root 5 on this side and 1 on this side. To find out hypotenuse, let us use Pythagoras theorem, that is under root 5 whole square plus 1 square. See, under root and square gets cancelled and 5 is left. 5 plus 1 square is 1. So 5 plus 1 is 6, which is nothing but root 6. Now this hypotenuse will be root 6. Now take a compass, put at the center O, take OG. OG as the radius, draw an arc. Yes. Let us locate root 6 on the number line. Now, after locating, again let us draw a perpendicular line to OG. That is at right angle with 1 unit length. Right? At right angle of 1 unit length. Now let us join this line. Now this point becomes H. Now we have root 6 on this line and 1 on this line. To find hypotenuse, let us use Pythagoras theorem. That is under root 6 whole square plus 1 square. If you see, under root and square gets cancelled, only 6 is left. 6 plus 1 square is nothing but 1. So 6 plus 1, it is equal to 7, which is root 7. Now let us write this as root 7. Now taking O as the center and OH as the radius, draw an arc. Yes. Let us locate root 7 on the number line. So, see, we have constructed a square root spiral for root 2, root 3, root 4, which is nothing but 2, root 5, root 6, root 7. We can keep on constructing. But I have shown you a method how to construct square root spiral. The remaining topics will be covered in the next video. You are welcome to contact us on Telegram to clarify your doubts regarding these topics. Check out the link in the description. Thank you for watching. Please do like, share, comment and subscribe to GeopByte.
GeopByte.